welcome back to Mrs. Thompson's classroom. Again, we're going to continue our unit on graphing trig functions. Specifically today, we're going to be talking about the tangent function. So let's review just a little bit. In our intro video, we talked about the basic shapes of the 6 trig functions, and this is what tangent looked like. It was based on our unit circle. Tangent is sine over cosine. And so at 0 degrees, that means tangent is 0 over 1, which is 0. So it starts here at the origin. Tangent of pi is then 0 over negative 1, which is 0. So it hits the axis again. And then at pi halves and 3 pi halves, we end up with 1 over 0. So that's undefined. And so we get these vertical asymptotes at all of the pi halves. Okay, so x equals k pi halves is an asymptote as long as k is an odd integer. Okay, our range is all reals and our domain is simply x not equal to the k pi halves for k an odd integer. Now, one way this tangent function is different from sine and cosine is that we notice its period to get one cycle is pi. Okay, cosine and sine were both 2 pi. But now this is only pi because I only have to get halfway around the circle to get all of the possible values of pi. Okay, also note that at pi fourths and 3 pi fourths, all the pi fourths are where it hits this 1 and negative 1 value. So if we have an amplitude change in these functions, it doesn't affect the height of a wave. It simply makes the curve steeper. Okay? All right, so let's do some transformations of these. So this number in here acts like a horizontal shrink by a half. Okay, we've learned that when we did our unit on transforming functions. So what this does is it changes the period. And the period is normally pi, but we're going to multiply it by a half, so we get pi halves as the period. Okay, so for tangent, normally the start is at 0, 0, and the end of the first cycle is at pi 0. But if I am changing this period, now my end becomes pi halves, comma 0. Because I have shrunk the period. So I'm going to have a 0 here. I'm going to have a 0 at pi halves. Now, where does that put the asymptotes? Well, the asymptotes are going to be your midpoints. So the middle is now at x equals pi fourths. That's halfway between 0 and pi halves. So if you do 0 plus pi halves and divide by 2, you'll get the midpoint. And that's where our asymptote belongs. Okay, now I can continue this pattern as often as I like. So I can do 0 and an asymptote, a 0 and an asymptote. So all of these values are a fourth apart. So this will be 3 pi fourths, and this will be at pi, which makes this at 3 pi halves, and this is going to be at 5 pi fourths. I can also go to the left, so I'll have a dot and an asymptote. This will make negative pi halves, and I'll get a dot and an asymptote. Now, what does tangent do in between the asymptotes? Well, there's no change here in amplitude, so our A value is 1. So halfway in between the 0 and the asymptote it's going to equal 1. And on the other side, it'll equal -1. So then I can connect the dots. It increases towards the asymptotes on the right. And I can graph as many cycles as I choose to. Okay. All right, let's do another one. So now we have this minus a pi-4ths in here. This causes it to move right pi-4ths. We call this the phase shift of a trig function. So I'm going to mark pi-4ths. That means my start, which was at 0, 0, has now been moved to the right pi-4ths. So now it's at pi-4ths 0. So I plot a point right here. Okay. My period, the number in front of the x is a 1, so my period is still pi. Now that's 4/4 pi. So I can count from this 0 I marked and go 1, 2, 3, 4, assuming I make my tick marks in fourths. Okay, so 1/4, 2/4, 3/4, 4/4, 5/4. Okay, so my end, which is normally at pi 0, is now at 5 pi-4 0. So the way we find the end is we take the phase shift and we add the period. Okay. Now halfway in between, we'll find our asymptote at the midpoint. And so that's going to be the pi-4 plus the 5 pi-4 divided by 2, which is 6/8, or 3/4, which we can see is right in between here. So this is my asymptote. Halfway between the 0 and the asymptote is where I would normally go up. But what does this minus do? This makes it a reflection. So instead of going up, I'm going to go down. Okay, so we'll mark that as -1. So I'm going to come down towards this asymptote. So let's find my other asymptote. So between the 0 and the asymptote, it's a count of 2/4. So I'll go 2 this way and mark another asymptote. And on the other side of this 0 then is where I will go. So there's one cycle. So let's finish another cycle. So I expand my asymptote out here. So this is at 5/4, so this would be 6, so this would be 7 pi-4. And I'm going to go down. So what the negative does is it makes the negative in front makes it a decreasing function. Okay. All right, now this has all the things, well, not all, we just don't have a vertical transformation, but we have, in general, you can have your function looking like this. Hold on a minute. Let's get this written right. Okay, and the period is found by dividing the original period by that in value. The phase shift is going to be our B value here. Okay, and the A in a tangent just tells us how steep we're going. So in this function, my period is pi divided by 2, and my phase shift is pi fourths to the right. Now I need a common denominator in order to count all my tick marks. So I'm going to make that pi halves, 2 pi fourths. My phase shift tells me where to start, so I'll mark pi fourths at a 0. That's my start to my cycle. Okay. Then I can count my period, so the end will occur at the pi fourths plus the period, and that'll get me at 3/4. Okay. And so halfway in between those zeros is my asymptote. So in this case, that ends up at pi halves. And then, so now I can see that from 0 to asymptote to 0 to asymptote, it's just a difference of 1 tick mark. So I can keep going however many times I want. I'll call that sufficient. The A value is a positive 1, so I can go 1 and -1 in between each of these. So if that 0 is at pi fourths and the asymptote's at pi halves, those 1 and -1 values are all at eighths. So this one right here is going to be at pi eighths if I want to mark it, and 3 pi eighths. And then I simply connect the dots. And they look like cubic functions, but they get bound by those asymptotes. Okay, so hopefully that gives you a little idea of how to do tangent. Let me just show you one more thing. If the function is written in this manner, so I have a tangent nx minus c, where the n value is not divided out, there's not an extra set of parentheses in here, then I need to divide the n out. So my phase shift ends up being the quotient of c divided by n. So for this problem, my period is pi over 2, because n is 2. My phase shift is going to be pi thirds divided by 2, which is pi sixths. And the plus, I need it to be minus c. So the plus means I'm going to the left. So the first thing I'm going to do is I'm going to mark negative pi sixths as my start. Okay, I'm going to take the period and make it 3/6 so that I have a common denominator. Then I can count over from my dot that I drew, 1, 2, 3. And where does that end up? This is pi sixths, so this would be 2 pi sixths, or a third. Okay, so negative pi sixths plus 3 pi sixths gives me 2 pi sixths, is the end of the first cycle. Okay, halfway in between, if I come over and I find halfway in between is my asymptote. And I can draw another cycle by going 1, 2, 3 again and drawing an asymptote halfway. I can go to the left. And then again, I can draw my curves. Okay. All right, so next time we'll talk about cotangent. Hopefully that helps today, and we will see you next time. Be sure to comment below if you have any questions for me, and we'll see you next time.